Yes, we are recording. Come on through. Now, the next big unit, and I'm going to make it a unit even though it's only one or two sections in the textbooks, is solving trig equations. All right. If you can solve trig equations, there's a lot that you'll be able to do in Calc 1. There's lots you'll be able to do if you have to take trig over next year for college. But if you can solve trig equations, it's a big deal. If you can't solve trig equations, the second week of calculus, there's going to be problems you can't do. All right? If you can't solve a trig equation. Now, what I'm going to do to try to motivate you, try to make this a big deal, is we're going to have a solving trig equations, and I'll put it off until Monday, May the 3rd. That's all that's going to be on it. All right? It's going to be worth a couple hundred points, like 250 or 300 points. All right? Now, with it, you're going to have to turn in a trig equations packet. That packet will be every problem that I've assigned on solving trig equations. All right? There's going to be a bunch of them. So I'm going to assign every one of them I can find in every trig book that I can find that are good problems. Okay? So tomorrow, I'm going to lecture today, make video. Tomorrow, when you see the assignment on the first packet, the first part of it, you better be working on it. Okay? Then Wednesday will be lecture notes again, more problems Thursday. Then Monday will be lecture notes and more problems. And I'm going to try to record every lecture that's on the new stuff. All right? Now, I'm going to start off by doing just a little bit at a time. I'll be honest, in a lot of the trig books, they put a lot of this in one unit, one section. I'm going to try a little part. All right. Solving trig equations. So Monday, May 3rd is when it's all going to be due. The bonus exam that you were going to take tomorrow, you're going to take this Thursday. If you can't take it this Thursday, we'll figure out a way to take it on Friday. Fair enough? And that'll get us for the bonus. I don't know how many people in here really needed it, but I know there was some that wanted it. All right. Solving trig equations. And what I'm going to do is we're going to start off in Margaret Lial's textbook, and I'm really going to just work examples that are in the book. So I think that gets you started. All right? And I can try to do this. Example 1. Example 1 says 2 sine theta plus 1 equals 0. All right. If you only have one trig function, isolate it by itself, just like you would x. Make it whatever the trig function equals. Okay? Can't do that, I know, if you've got multiple trig functions a lot of times, but if you only got one trig function, what's the first rule? Make it, set it by itself, get it by itself. So in this case, you would get sine theta equals -1 divided by 2. Isolate the trig function. If you've only got one trig function, isolate it. Once you get the trig function isolated, like so, we're going to work in radians. All right? I'm going to work in radians. Some of the assignments in the book are in degrees. Do those in degrees. It's easy. But we're going to look in radians today. And we're going to always look for our answers between 0 and 2 pi. We want to look on the interval 0 to 2 pi. Okay? Now, that means you're going to look around the circle one time, looking for your answers. If you don't use your unit circle and you try to do it on a calculator, you're not going to have all the answers. All right? You're not going to have all the solutions. You're not going to have all the places where it works. So, and if you put 2 pi on there, I'm not going to mark it wrong because that's okay. You can put 2 pi in there, but really the intervals, when you see this on testing, it'll say 0 to 2 pi, and it won't have a bracket there. All right? Everybody happy with that? Understand the notation. Okay, once you get to here, look at your unit circle. tell me, where does the sine of theta equal negative 1/2? Just look on your unit circle and pick them out. Should be two of them. Where does it equal negative 1/2, the sine of theta?
11/6.
That's one of them. Yes, sir. Where's the other one?
7/6.
Thank you very much. Now, in all honesty, you could also tell me it was negative pi over 6. All right? If you told me negative pi over 6, that would be okay. Matter of fact, when you're in calculus, it'd be nice to know this one. All right? But when we're solving these, we usually just go from 0 to 2 pi. But if you threw that in there, that's not a bad thing to know. All right? Everybody happy? Everybody knows how to read a unit circle, right? I'm not going to say anything negative like on that first exam. Some of you didn't. If you don't have a purple unit circle, we need to get you one. I got some purple ones back there that you can make your unit circle from. All right? If you don't have a purple unit circle, we got to get you one. Okay, questions. Single trig function. Get it by itself, and then do what? Look at your unit circle. For right now, everything we do will be on the unit circle. I'll tell you what to do when it's not. All right. Example 2. Sine theta, tangent theta equals sine theta. Now, let me give you the first note on this. You cannot divide sine theta out of both sides. You can't do that. If you divide out a variable, you lose an answer. You can't divide out a sine theta. Fair enough? Okay, you can't say, oh, I'm going to divide sine theta from both sides. That'd be like when you had the x's and you would divide out an x, and all of a sudden you lost an answer. Same thing, you'd lose an answer. In this case, you can't isolate the trig function. Everybody okay? You can't isolate it like you did over here. Set it equal to 0 and factor. When you have multiple trig functions, the first thing you want to try to do is set it equal to 0 and factor. All right? When you have multiple trig functions, you can't isolate just one of them. Set the whole thing equal to 0 and factor. Factors work best when it equals 0. Okay, when it doesn't equal 0, factoring, it really doesn't help. All right? You want it equal to 0. Now, we're going to factor, what can we factor out of both these? Sine theta. Everybody okay with that? Everybody's kind of looking at me like y'all are asleep, that we're in late into April. And tangent theta minus 1 equals 0. Once you have it equal to 0 and it's factored, you learned in Algebra 1 and Algebra 2 this thing called the zero principle, where you could set each factor equal to 0. Remember that? Setting each factor equal to 0 in Algebra 2? Yeah. Okay. Well, that's what you do. Sine theta equals 0, and tangent theta minus 1 equals 0. So tangent theta equals 1. Once you get here, you do what? Look on your, say it please.
Unit circle.
So yeah, unit circle, just so I feel like I'm accomplishing something here. Unit circle. Okay, when you look on your unit circle, where does sine equal 0? Where does the sine equal 0?
Pi.
2 pi is an okay answer. Where else?
Pi 0.
Pi and 0. Yeah, 0 and 2 pi are the same place. If you put the 2 pi in, I'm not marking it wrong, but you don't have to. Okay? All right, now tell me, where does tangent of theta equal to 1? Where does tangent theta equal 1? This is scary if y'all really are. Y'all just ignoring me and not wanting to say anything? Or you really can't find it?
Pi over 4.
Pi over 4, and where else? Where else is tangent theta equal 1? 5 fourths pi. Make them look bad. It won't bother me. They don't want to raise their hand. They don't want to answer. Well, smart. Make them look bad. All right. And then sometimes people say, well, do I have to arrange them in order? It makes it easier for me to grade, but no. You can leave the ones for sine theta there and the ones for tangent theta there. If you try to work this in a calculator, you'll get that answer and you'll get that. That's all you'll get. And you'll have a whole bunch of stuff you don't know that you need to know for the future. So we have multiple trig functions. You might want to try to do what? Set it equal to 0 and factor. If you have one trig function by itself, life is pretty good. All right, next question. Got one I want to work here. I think I do anyway. Let's see. I'm looking for things to. Here we go. Now, we'll work a few problems out of her assignment, and then I'll come back and work one or two examples. She has some special cases in her textbook, and we'll get to them, but you don't want to see them the first day. All right, example 3. Here we go. The students can't say, oh, he didn't do anything. It looks like the homework or the classwork. All right. Number 22. This is from Lial 6.2, number 22. It says 2 cosine squared theta minus cosine theta equals 1. Notice how you have that squared term, right? When you saw x squared, you know you had to set it equal to 0 and do what? Factor, right? Is that okay? So that's what you're going to do here. You're going to set it equal to 0 and factor. 2 cosine squared theta minus cosine theta minus 1 equals 0. Factor. But Mr. Evans, they taught us this tree factoring. Okay, you can keep up doing that, you do it. Mr. Evans, they taught us the slip and slide factoring. Well, you probably are slip and sliding in the mud. All right, you factor it. And there's a minus sign here and a plus sign there. Do you notice 2 cosine theta times cosine theta is 2 cosine squared theta? It factors. It's a trinomial. So you use your trinomial factoring. You set each factor equal to 0. And after you set each factor equal to 0, you get cosine theta equals -1/2 and cosine theta equals 1. And then what do? You look on your circle. Is everyone okay that that's like 2x squared minus x minus 1 that you're factoring? If you had to, think about it that way. All right. Okay. Look on your unit circle and tell me some answers. Where would those be on your unit circle? Cosine theta equals -1/2.
4/3 pi.
4/3 pi.
2/3 pi.
2/3 pi. I like that. And then where does cosine theta equal just plain old 1?
0.
0 and 2 pi. If you put 2 pi down, I won't mark it wrong, but 0. And so there you go. If you're having trouble factoring this, just think of it like this. 2x squared minus x minus 1. And think, how would I factor that? Because the cosine theta is that x. All right? Does that help? Give you a hint on how to factor? No, I cannot. All right. Where'd my book go? There we go. Now, let's look at another little problem that might involve some factoring. They actually have this one already factored for you. This is number 17 in the book. And it's already factored and it already equals 0, so the factors are good. Cotangent x minus 1, and then square root of 3 cotangent x plus 1 equals 0. All right. It's already factored, it already equals 0, so you just have to set each factor equal to 0. So cotangent x minus 1 equals 0. Square root of 3 cotangent x plus 1 equals 0. And the reason I'm doing this one is to tell you how to deal with secant, cosecant, and cotangent. That's what I'm trying to do here, is teach you how to deal with secant, cosecant, cotangent. Because those are not just written right there for you on the circle. The cotangent of x is equal to 1. Well, the reciprocal of cotangent is what? Tangent. What's the reciprocal of 1, folks? 1. You don't change the sign. You just take the reciprocal. All right? Don't change the sign. Then you just look on your circle and tell me, where does the tangent of x equal 1? Someone tell me, where does the tangent of x equal 1? Pi over 4. Where else? Just a positive one. Where else? 5/4 pi. Now, over here, you get cotangent x is equal to negative 1 over the square root of 3. So what are you going to do? You're going to make that tangent x is equal to what? Negative square root of 3. See how we can deal with that cotangent? Just take reciprocal. Don't change the sign. Just take the reciprocal. Y'all are smiling because y'all just took the test.
Yes, sir.
What test did y'all just take?
Yes.
EOC, okay. Now, get your unit circle out. You'll need it. So now, look on your unit circle and tell me, where does tangent x equal negative square root of 3? Where does that happen? Someone?
2/3 pi.
2/3 pi. I'm going to trust you.
5/3
And how much?
pi. 5/3
5/3
pi.
pi. 2/3 pi. And those are all 4 of your solutions for that. And why did I pick this problem? I wanted to show you what to do about these cotangents and secants. Just work them out, and then when you get them isolated, do what? Take the reciprocals. All right? And then once you get to here, you do what? Look on your unit circle. Happy so far? And I'm making a video for those of y'all that are late, so you'll have a video to look at. It also explains when your next test is, which is going to keep some of y'all from making an A in here. If you bomb the first test, and you bomb this one that's coming up, you're going to make a C or a B. This is big stuff. This is the serious part. For a lot of students, this is the hardest section in the tree. Because you got to use your unit circle and know algebra. Notice everything we're doing is really algebra, bunch of factors. All right. I'm looking for certain types, certain problem. Oh yeah, one we got. I'll make up the problem. Here we go. 2 sine squared theta minus 1 equals 0. I want to talk to you about what to do with. Now, does everybody agree probably the best thing to do is isolate that sine squared, just like we isolated the sine x earlier? So you isolate it. Sine squared theta equals 1 over 2. This is Evan's example. The reason I'm giving you this example is because I want to show you what to do with the square. This example is all about what to do with that square when you can isolate it. You're about to do what? Take the square root. When you take the square root, please remember that it's no longer a principal square root. You're taking the square root, so it can be what? Positive or negative. And that's what students don't do. When you take the square root, it can be what? Positive or negative. So you take the square root, positive or negative. And square root of 1 is 1, square root of 2. Once you get there, you look at your unit circle. Once you get there, you're ready to look at your unit circle. And when you look at your unit circle, tell me, where does the sine of theta equal positive or negative 1 over square root of 2? Pi over 4. Where else?
5, 6, 5.
Oh, not 5, 6.
7 over 4 pi.
7 over 4 pi is a good one. I'll take that. What else? Positive or negative? 1 over square root of 2. 5 fourths pi. I'll take that.
3, 4, 5.
And 3/4 pi. Now, let me tell you the difference between the test you're going to take from me on Monday, May the 3rd, and the test when you need to know this for college calculus. Yeah, can you imagine spending 15 minutes working a college calculus problem and you get to this equation and you can't solve it because you can't do the trig? In college, you won't have your unit circle to look at. I'm going to use yours because yours is pretty. You would just have to know this circle in college. All right? You wouldn't have the list of all your trig identities that you're going to need written on the back like you will for my test on May the 3rd. In college, it's all got to be in your brain. All right? But for y'all, I'm going to let you bring, as long as it's on purple page, I'll let you bring your unit circle and take the test. Okay, now, work another one here. This is number 22 out of the book. 22 out of the book. And then we'll try to pick something a little harder here. Wait, I said 22, that's not right. 34 out of the book. 34, right out of the textbook. Cosine squared theta minus sine squared theta equals 1. No, equals 0. Notice it, R equals 0. It's cosine squared minus sine squared. What am I hoping you think about doing to that since they're squared? Can't take the square roots because you have to square the whole thing, which would be complicated. You could take the square root, but you'd have to get them isolated. What I want you to do is, yes ma'am, Miss, last name? Gatzenberger. Miss Gatzenberger is exactly right. We want to see a factoring situation. Okay, just in case. If you see x squared minus 16, how many of y'all know that factors in x plus 4x minus 4? Right? Okay, it's called the difference of two squares. A squared minus b squared factors into a plus b, a minus b. That's on your ACT exam a lot, right? How many of y'all took the ACT on Saturday and saw an example where there was like an x squared minus 16 or you needed it? Yep. Okay, well this factors into cosine theta plus sine theta, cosine theta minus sine theta. And we're going to come back and talk about taking the square root in a second, but I really don't, I like doing it this way. I like factoring it because it's an a squared minus b squared. So you set each one of the factors equal to 0. And you get cosine theta equals the negative of sine theta. And you get cosine theta equals sine theta. Well, let's just talk about the cosine theta equals sine theta. Where on your unit circle does cosine theta and sine theta equal the same thing? Where?
3/4 pi.
3/4 pi is one of them, and what's the other one? Quadrant 1, what is it?
Pi over 4.
Pi over 4. And 3/4 pi is not right, is it?
Yeah. No, because it's in
How about 5/4 pi? But what about that 3/4 pi? In the 3/4 pi situation, one of them was positive and one of them was what?
negative.
Negative. Notice, positive, negative. So 3/4 pi would be this one. And what else? Not just 3/4 pi, but what? 7. Let me write it in the right order. 7/4 pi. Because what's happening is here, they're either both positive or both negative, but here they have different signs because one of them is positive and the other one is what? Negative. Okay? Now, back to the man, Mr. Beckham said, take the square root. And he's not wrong. It's just not the way I want to work it, but I'm going to show you what to do.